this. How's it going, Jaya?
Very good, very good. Alex Pruden, CEO of Aleo, who we are all waiting for, is here in Istanbul as well, which is where I'm calling in from. And he was just giving a talk, so that's why he's a bit delayed. Sometimes talks can be very successful, and you get loads of questions afterwards, and it's very hard to get out of the hall. So hopefully that's what's happening.
Why he's a bit delayed. Sometimes talk.
There's a bit of echo.
How's this?
Nah, much better, much better.
Okay, good, good, good.
What about you, Max? Are you also in Istanbul?
No, I'm not actually. For once, I'm not. I'm actually at home, not traveling, which is also quite nice. I did quite a lot of traveling earlier in October, so no, I'm just been kind of overlooking the hackathon stuff as well as looking into some FFI stuff, which means that people who have applications in languages other than TypeScript or Rust might be able to, in the future, use our SDKs, which is quite nice. So yeah, I'm doing a bit of research on that.
Super. And how are the projects shaping up on the builder track for the hackathon?
Yeah, looking good. We've got some interesting stuff kind of bubbling away and coming in. So we'll be having a look at them next week, and then announcing stuff.
Hi, amazing. Nicole. Hi, Matthew. Good to see you both again.
Jaya,
yes.
Where are you in Istanbul? Can you talk about that a little bit?
Yeah, well, right now I'm in a Hilton hotel with an incredible view. I popped back because I was in a very noisy hall before. I was at the Autonomous Worlds Assembly, which is happening alongside DevConnect, and is one of my favorite. Actually, it's such a good event. For those who don't know, it's a crew of people who have been building on-chain games and have this kind of concept around games of autonomous worlds where instead of trying to build kind of closed worlds that then players can come in and explore, it's kind of open-ended narratives where players also construct the world as they go along and create new rules and that sort of thing. So it's a very different type of storyline, a very different type of experience. So I was there listening to some talks. Some really great speakers talking about the kind of thinking behind how to set up the initial building blocks so that loads of new worlds can flourish from there. And it's actually quite a nice metaphor for what I would love to talk to Alex about later on when he joins as well. So the building blocks, of course, being privacy primitives rather than gaming or building. Yeah, I think it's a good thing to think about privacy from a more positive as well as something that you start off with primitive and allow people to actually construct entirely new ways of interacting and engaging with each other.
Any games that we should be any particular games that we should be keeping an eye on?
Well, Max can talk about that because Max has been testing some of the autonomous games.
I have. I'm trying to remember exactly what it's called because I know the people who made it. So because of that, I didn't remember. I've been testing one of the games, which is, I believe, at the Autonomous Worlds, actually at the event. They've also set up a bunch of computers, right? So people can actually be testing them out, right, Joe? Like people are playing them there as well, right? So, yeah. I have been playing one of the games, which is coming out from some of the people at Trust, Arb, and a bunch of other people, which is, I'm going to do it a disservice now when I try and describe it, but I suppose it's a text-based, I don't know, maybe you'd call it puzzle, maybe you'd call it a resource management game, kind of like Factorio or something like this, with initially it looks very dystopian kind of interface. You're a worker kind of sorting out orders, building solutions out of components and trying to make different things is the only way I can properly describe it. But yeah, let me find the exact name of it and I'll come back. But it's a great game. And then, yeah, I don't know, the autonomous worlds thing is actually quite interesting, right? Because it's kind of a full circle as well to a certain extent. It was, you know, some of the, at least when I was getting into, you know, way before it was ever referred to as Web3, but kind of blockchain stuff and decentralized stuff, actually having, you know, in-game assets that you control, or autonomous in-game assets and stuff, right? That was actually like really early use cases, wasn't it, of this kind of stuff before before asset became a word that everyone was used to, but also became a lot broader in terms of what it could possibly mean. So yeah, actually seeing this now crop up is actually quite interesting, because it's almost kind of like the infrastructure or the tech has actually caught up to ideas that people were having, like, I don't know, what, 6-7 years ago now.
Yeah.
Yeah, interesting.
A lot
It's
of
funny that
the
we're talking about Web3 gaming, and here I am replaying the original Portal from like 25 years ago. Anyways, sorry, Jaya, go ahead.
No, I was just gonna say that a lot of the conversation at the event today was also about this, you know, the aspect of autonomous worlds being, you know, and this type of gaming, being that it's not very easy to draw the boundaries around it. So where the game actually ends, or what you even kind of define as a game, right? So, you know, if we're thinking about like the even the kind of like economic or the token economic designs that people come up with, can also be seen. I mean, that's essentially kind of a set of rules for a set of economic games, right? And so, like, you know, that was it. A lot of the kind of like, there are some games that are kind of recognizably games that have boundaries, but then, you know, the autonomous worlds is kind of like there's a lot of fluid boundaries where it spills over into other mediums as well. And people are talking about fan fiction and how people, you know, take games to kind of the physical space and to social media and that sort of thing. So how it kind of permeates across platforms and stuff like that too.
Which is also, I mean, if we're kind of also harkening back to older stuff, I mean, definitely one of the things that got me interested in all this was that Josh Stark's definition of crypto economics, right? Like that, it was, I think it was initially a blog post, or it was a couple of blog posts of, yeah, having, you know, crypto economics as like game worlds, right? It's almost like toy worlds, almost like this Conway's Game of Life kind of thing, but with organizational structures. So yeah, it's really cool to see a lot of those ideas like re-permeate.
A question from Morgan. Oh, sorry to cut you off.
No, it's all good.
Oh, did we lose Sudo? But yes, the question from Morgan. Yes, they are permissionless, and yeah, I think you should just dive in and try them out. I haven't personally kind of dived in yet. I'm more kind of on the theory side, but have a look. It's very much in the Ethereum space, as far as I'm aware.
Do you play games, Jaya?
You know, I used to, but I haven't played games in a long time. I was a bit of a kind of like magic card nerd when I was a teenager for a minute. I played Civilization as well, which kind of weirdly influences my thinking. Not the strategy part of it, but more the kind of graphics part of it. Yeah, but lately I haven't.
Bird's eye view kind of thing.
Yeah, and the kind of like the squares that appear as you kind of like move step by step, you know, like you have the kind of like void, and then like, you know, kind of, yeah, and the building and stuff. Anyway, yeah, but I haven't played games in a long time. I do love one of the things that has always interested me about reading white papers, though, has been the kind of game aspect of it. So the fact that when you're reading white papers, you are essentially reading a set of rules that immediately kind of like instigate a kind of certain mental model of a world almost. So to me, like that's I see white papers almost as kind of like it's a narrative form to my mind, in the way that my mind reads white papers, and that's what I find so kind of like poetic about them. I mean, then I have a kind of a bit of an ambivalent relationship to it as well, though, because there's a slightly more kind of like sinister history to literally game theory, as a subdiscipline of like more unorthodox economics, right? And that's kind of, where game theory does have a lot to do with a certain kind of like social engineering that I don't think is always necessarily very beneficial or the right way to go about making collective decisions as humanity more generally. But for specific uses and specific like functions, I think it's very interesting. And for something obviously like something like the NIM mixnet, an isolated case like that where we're trying to build a very specific infrastructure to service very specific needs, I do find it to be quite a kind of fascinating set of tools.
That was
So
a
Max is no Jaya spawning noobs and white papers. What games do you play, Max?
well, to come back to what I was saying before. So the game that I've been test playing is called This Cursed Machine, which I think they're quite rapidly iterating. I think so. I imagine it will be, if it's not online yet for everyone to play, then it will be probably after the Autonomous World Summit. And yeah, with regards to the game theory stuff, there was a wonderful piece by the Sarah Friend wrote like a good couple of years ago now, where she also was referring to the fact that like there was the same experiments were done, but on a essentially a different group of people, right? Like the original kind of experiments of game theory were done on like a very specific group of people, which generally were also like, students in the like political economy students, right? Which at the time was like a very narrow slice of the population. And actually, when the same experiments were performed on like other groups, if anything, then it kind of it really deviated from the results. Is basically what I'm saying. So like there was the canonical like game theory, the supposed canonical like outcomes of the game theory experiments actually really only necessarily applied to like quite a narrow slither of the population that they were applied to. And when you applied them elsewhere, it was people preferred collaboration, which is not necessarily talked about as much. But yeah, kind of interesting. Yeah, in terms of my own gaming stuff, then I have a bit of a love-hate relationship with it because I try and avoid it when I'm doing other stuff because otherwise it takes over my life. But yeah, I mean, yeah, this stuff is kind of games. But more recently, then I got back into playing EVE Online quite a lot last year.
Oh, really?
Yeah.
So I think the guy that runs EVE Online was also at Autonomous Worlds. He was there for the first
Sick.
London Summit as well. Yeah.
Yeah.
He's a very interesting speaker, actually. Hi,
It is.
Alex.
Hey.
Hey, how's it going, guys? Can you hear me okay?
Yep.
Yeah,
We hear you fine.
loud and clear.
Awesome. Yeah, sorry, I'm at the a conference in Istanbul here today. I just got off stage, so appreciate the flexibility on the timing. Sorry, I was a little bit late. Hey, everybody.
That's totally fine. I'm in Istanbul as well. I just ran back to my hotel room. Yeah. We were
Nice.
just talking about the Autonomous Worlds Assembly, which was where I was at this morning.
Oh, cool. Nice. Yeah, I'm at Pragma. I was just on a panel with a few other folks from the ZK space, Scroll and Aztec.
Nice, amazing. Cool. So, Sudo, do you want to do a little round of introductions? And for the people who've just dialed into the live stream, we were just hanging out, chit-chatting for 15 minutes as we waited for Alex to join us. Alex has now joined, so we can kickstart the kind of official part of the program.
Exactly.
Yeah,
So, like,
Sudo, do you want to go ahead?
I believe this is our first guest lecture, so I'm super excited about this one. We have Alex with us today, who's the CEO of Aleo. Am I pronouncing that right? I never know how to pronounce Aleo.
Yeah, we explicitly made it very difficult for people to pronounce. So there's many variations. Several of our advisors also mispronounce it if it makes you feel any better, but the canonical pronunciation is Aleo, rhymes with paleo. So at least that's what I say.
All right, I'll try to keep that in mind. Really good call on making it as confusing as possible. I also do that with everything I can. All right, welcome to the stream. Please introduce yourself for those who may not know you from the NIM community.
Yeah, sure. So my name's Alex Pruden. I'm the CEO of Aleo. I was actually not a founder. I was the first employee. Joined Aleo at the end of 2020. Was it the end of 2020? Yeah, it was the end of 2020. Before that, I had been in venture. I worked at A16Z Crypto. And yeah, I'd gotten there through a class that I was taking in grad school at Stanford University. I was an MBA student, but I was moonlighting in the computer science department, taking classes I had absolutely no business being in, since I had no technical background whatsoever. But my professor was an advisor to A16Z at the time and introduced me, and that's how I got that job. Before all of that, and the way I got into crypto, I was a U.S. Army officer for 9 years, and I was working actually in Turkey with Syrian rebels at the time, 2016, 2015. This is back when there was an effort to train and equip Syrian rebels to overthrow the Assad regime. An ill-fated effort, I guess we can now sadly say. But a lot of the people I interacted with in that, as part of that, were people who were refugees, had lost everything. Obviously, of course, in addition to the tragic loss of life and everything associated with that, I think there was very real financial consequences, right? People who became refugees, who were lucky enough to flee with their lives, got to Turkey or got to Jordan or Lebanon, and, had no longer had access to their bank accounts or their real property, which represented the majority of their wealth, was obviously still in Syria. And they were living hand to mouth, even people that had been relatively well off before the conflict. And I discovered Bitcoin here in Turkey, and, kind of just this idea that you can have, the idea of a bank account in your head that you access via, memorizing a seed phrase that corresponded to a private key that you could take anywhere across any border, was what really excited me and got me into the space.
All right. That's a beautiful
Wow.
story. Do you have a counter story for that, Jaya? People already probably know you in the NEM community, but
Slightly less like epic storyline, let's say. But yeah, I was I guess organized in various kind of groups of people around Europe that were very interested in decentralization in one way or another. Including Indie Media way back in the day. So Indie Media was a decentralized network of media producers that came up around the kind of anti-globalization movement way back. And a lot of them, were developing new types of technology that actually led to Web 2 initially. And a lot of people in that space carried on thinking and developing around decentralized technology in the years to come after. And I was dipping in and out of that, and then read the Bitcoin white paper probably around 2011, and found it very interesting as a piece of writing, actually. I thought it was quite phenomenal that you can cram so many ideas into 9 pages, spawning all kinds of imagination for all kinds of people for very different reasons. And then many of the first, both Bitcoin and Ethereum, I remember the first Ethereum DevCon in London, walking into this, literally a golden hall in the financial district of London, and seeing this weird mix of like people with dreadlocks, crusty punks, bankers, and a couple of early investors that were interested in what was going on in that space. And it was just honestly the most surreal mix of people. Yeah, not long after that, I decided to write a PhD, which was a political analysis of the Bitcoin and Ethereum protocols, looking, deeply into the kind of the white papers to try and understand, how come you can have such contradictory mixes of people from different political backgrounds, literally contradictory economic outlooks on the world as well, that come together and try and create something new out of this. So I was interested in trying to kind of map that out on its own terms. This was a time when there was a huge hype around crypto. So I was writing a PhD around 2016, 2017. But also a lot of critique that was coming up. So it was becoming increasingly polarized. And I wanted to try and kind of step back from that polarization, and try and take an honest look at what was novel that was emerging from this space that deserved its own type of description, rather than a kind of like typical critique from the left, typical critique from the right, or whatever else. So that was my kind of introduction into crypto, and then I also kind of just know the founders of NIM for many years, so jumped on board with NIM a couple of years ago.
Well, that's awesome. And I guess obviously we have different backgrounds, but I also love the space because it's so diverse in terms of different backgrounds. And I think that's one of the things that makes it super special, right? It's not just, there's aspects of it that are obviously very deeply technical on the cryptography and networking, computer science side, but there's also very political aspects of it, very economic aspects of it. And there's people come at it from all angles. And I think it's just, to me, it's one of the funnest parts about being in the industry is it really brings that diverse group together.
Definitely. So actually, to also introduce Alex, you to a little bit the context of this talk and the invitation to jump on board. Pseudo, you're not correct. This is not the first guest speaker we've had on board, because in fact, kickstarting Shipyard Academy, we had a whole bunch of guests from UPA, the Universal Privacy Alliance, and we had Rose from DarkFi as well recently, and. So
Those were
in
fireside chats, though, boss. This
fair
is
enough,
a
fair enough,
guest lecture.
fair
I was very
enough.
specific with my wording.
Very good. Just to say that Shipyard Academy is basically a 6-week educational program about the NIM system, but also about privacy primitives more generally in the Web3 space. And that's why it's been very important for us to kind of bring other people on board, especially people that are part of the Universal Privacy Alliance or organizations that are part of the Universal Privacy Alliance, to give a little bit of a bigger picture of yeah, I mean, what I'm calling privacy primitives at the moment, but like the kind of different layers, the different aspects of privacy problems that the different projects address, right? So, NIM obviously addresses, the network layer privacy, but there's so many other kind of problems, and in order to solve the problem or to solve privacy in a holistic manner, we really need to get everybody in the room and start to kind of see how we can mature things and make the space kind of easier for developers to navigate and understand. So that's what we're trying to do here, is like starting to paint an initial picture of like what is the Web3 privacy space actually looking like. So thank you so much for joining us. And we also have Max in the room, who is NIM's head of developer relations. And I thought it would be great to get Max to also pitch in after your talk on how something like Aleo and NIM could actually interact for good. Yeah. Max, do you want to just
I'm already getting some good hard questions about why our tech is not working at the moment, which is, I was actually just having a conversation with someone in the hall that the beautiful part about existing as an idea, you guys at NIM obviously know this, the beautiful part about existing as only as an idea is that nothing can ever go wrong. But the second as soon as you move into the real world, shit breaks all the time. So to the individual asked the question why the testnet doesn't work, I would have to go and look. I'm sure there's something probably wrong at this moment, because there's something wrong at somewhere at every moment. This is part of being early in an ecosystem. So maybe just a blanket statement. I appreciate everyone's patience and willingness to learn and grow with us as we build this tech. So anyway,
on that note, sorry, go ahead.
Oh, no, you go ahead. I kind of had a question. The thing I was going to pose is I have sort of two versions of talks that I can give. I have a slightly higher level general talk about ZK specifically, with some Aleo bits thrown in, about why zero knowledge cryptography is an interesting primitive for computation, for privacy preserving computation, and it's kind of the background of that. So that's one direction that we can go. It's like I said, it's a little more general, a little more high level, but depending on what your audience is like, I didn't know if that would be worth it or not. I also have a talk about Aleo, specifically how it's architected using zero knowledge cryptography and all these primitives, what the economic model of it is, etc. And I know there are people talking about, how Aleo and NIM can interact. I think I can get into that about the potential two different, I think I view these as very complementary. So I'm happy to get into that later. But I guess like for the talk portion, for the learning portion, I'm kind of open to presenting either, whatever would be most useful to the audience.
Let's get a sense check in the chat, no?
Yeah, let's get a sense check in chat. But remember, guys, we've already gone through ZK technology quite a bit with the first fireside chat with Kenny and Ellen. But
that was
it's
more
up
of
to you guys, really.
Okay, so it looks like Morgan in the chat is saying ZK basics. Anyone else? Jimmy agrees. Can we have some more votes in the chat? Otherwise, let's just roll with that.
Yeah.
I suppose before the latter we could maybe do in the
I can also like
or something.
I can also like jump between if we need to. And yeah, I being in crypto, being the CEO of Aleo for a while, I have many versions of various talks that I can just queue up as needed. So okay, so maybe let me pull this one up. Let me get my
just 1 second before we get started.
Sure.
Guys, as always, there is going to be a Q&A afterwards. We're already collecting your questions. So if you have any questions to Alan, Jaya, Max, or myself, make sure to ask them in chat. We're keeping a close eye there. Yeah, take it away, Alex.
Okay, can you guys all see this? I want to make sure you guys can all see my screen here. Let me find you all again.
Yep, great.
Yep.
Okay, great. Sorry, let me just make sure I'm not losing. Okay, great. Okay, sorry. Just trying to get set up here so I can see both you guys and my screen. Okay, great. All right. So I'm just going to go through this talk that I have here, if everyone can see. Great. So, okay, so this talk is kind of more high level about zero knowledge cryptography, and maybe let me just talk about why. Yeah. So why this talk? So zero knowledge cryptography is actually, let me just get into it. Maybe first off, I made this talk on HackMD. I don't know if anyone wants to scan the QR code, but this QR code theoretically should link to this talk. I think I may have changed it a while ago, so if it doesn't, I'm sorry, but I'll update it after this. But I'll share the link with you guys so you can share this with everybody. But this is a public talk, so anyone is free to take this content, fork it, comment about how it's wrong or right, or they love it or they hate it. But feel free and add comments and suggestions directly in there. I had already talked about me, so we'll skip that. Okay, so talk about a little bit about the agenda here for this talk. So I'm going to talk about ZK cryptography, talk a little bit about what Aleo is. I'm going to talk about use cases, because Aleo is really basically implementing a specific type of zero knowledge protocol, and then we'll get into Q&A like we talked about. So, okay, short history of ZK. Two cryptographers walk into a bar is the start of what is probably a really bad dad joke that I would appreciate. But seriously, like the initial kind of motivation for zero knowledge cryptography was this kind of two cryptographers walk into a bar idea. It was this class of schemes called interactive proof systems, right? And kind of the motivation for this interactive proof system was mathematicians. I guess like apocryphally, it was mathematicians who were too lazy to verify each other's work, right? So you'd be a mathematician and you'd come to your colleague and you'd say, hey, I solved this long-standing problem. Here's the long proof. Kind of the motivating idea is like, well, if I just want to check that you solved this problem and know that you solved it without reading all of the gory details, it would be a good time saver, right? It was probably a professor of math or something that was giving students homework assignments, right? So this idea of interactive proofs, the motivation was to have a prover and a verifier, and the prover hands the verifier some result, and then the verifier basically asks some questions, and then afterwards the verifier accepts or rejects. And it turns out that this category, which is in complexity theory is called IP, can apply to a huge range of potential problems, right? And this is kind of the initial motivation. So this is kind of the starting point for what ultimately became zero knowledge proof. So this idea of an interactive proof, a transcript between, of a conversation between Alice and Bob, where it's like Alice makes a claim, Bob asks a question, Bob either accepts or rejects. So and the key thing here with the interactive proofs is that you can actually make this interaction shorter. I see I have a little bit of spelling error there. Sorry, but the idea here is that the interaction or the transcript is shorter or smaller by some measurement than rerunning the computation yourself. So basically, you're able to check more quickly than you do. And so you can people systems in ways that basically achieve certain properties. One is completeness. Completeness being this idea that, like, okay, if I'm proving a statement, it's like any statement that could be proven, I can prove with 100% probability, effectively, right? Soundness is this idea that, like, I can't prove a false statement to you, right? And then as kind of exploring the paradigm, what we ended up discovering was that there was a way for the prover via some other cryptographic primitives that I'm not going to get into in this chat, but I guess if people are interested in learning more about it, these are commitment schemes. So using a commitment scheme as well as an interactive proof system or an interactive oracle proof system, you can add in this property of zero knowledge, which is that the prover can not only make a statement, but they don't have to actually reveal anything about that statement other than the fact that it's true or false, right? And that's all the verifier learns, is whether or not the statement being proven is true or false, right? And that's where this concept of zero knowledge comes in. So formally, Zero knowledge means the verifier learns nothing about the statement being proven except that it's true or false. Now, so I have to step back here since this is the crypto world here. Maybe this is a good time to say that ZK has become these days a bit of a term of art, right? And a term of marketing, right? And I may be as guilty about of this as anyone, right? I'm running a ZK project, and so ZK can stretch or shrink to fit a lot of things, but the formal academic definition is what I just described. Now, many people in crypto also like ZK. They call ZK, like ZK rollups, for example. ZK rollups are really taking advantage of this succinctness property, this idea that the interaction is shorter than the computation, right? So that's kind of like a part of this. It's also, it's not strictly speaking a key property, but it's kind of a consequence of this model where you can have kind of shorter computations if you're just proving them as opposed to doing them. Okay, so anyway, so this is kind of this is the paper. So if you go back in history, I think this was published in '82, I want to say. This is the original paper, right? So this is the knowledge complexity of interactive proof systems. So you see, I mentioned IP as kind of the beginning of this kind of mode of thought. And these are, it's mostly two MIT professors. I think Silvio actually founded a project in crypto called Algorand. But anyway, he was basically one of the intellectual godfathers of the space, as were these two individuals, Shafi and Charles. Okay, so now how did we get from like IP to where we are today? So Aleo is built using a primitive called ZK snarks, and I'm kind of tracing here how we got from here to there. So interactive proofs plus zero knowledge. So basically like that paper that I just showed here, basically invented this concept of Sigma protocols, right? So you have it's a two-party, prover and verifier talk, and then the prover doesn't have to reveal anything. Like they just commit to some statement, and then they basically the verifier can open some non-revealing parts of the statement and verify that it's true. But there's still an interactive part of this, right? And this is what Sigma protocols are. So if people think this is weird, it doesn't make any sense, you've never heard of a Sigma protocol, I commonly use Sigma protocol in crypto is actually oh god, the signature scheme that I just blanked on, the one that Bitcoin just adopted. I'll think of it. I'll come back to it. But there's a Schnorr. There we go. It came back to me. Schnorr signatures is an example of a Sigma protocol. So Sigma protocols, alongside, if you take that Sigma protocol and you're like, okay, cool, I have this interaction. What if I don't want two parties to interact? What if I just want to make a general proof to the world that some statement is true without revealing, right? So you can combine a Sigma protocol with something called the Fiat-Shamir transformation, which is basically just like, you can just think I have like a little 8-ball there. It's effectively like you generate a big string of random numbers using a cryptographic hash function typically. And then you kind of like pretend as if those random numbers generated a bunch of random verifier questions, and then you commit to those, right? So you can basically, using cryptographic hash functions, you can effectively get a non-interactive version of this otherwise interactive scheme, right? And so then this is kind of what you guys NISX, which is non-interactive zero knowledge proofs, and then you take NISX and you kind of add some magic. I didn't have a good word for this, but basically, like there's certain types of commitment schemes which enable you to do this really succinctly, right? Specifically, a polynomial commitment scheme, which enables you to basically commit, a long statement down to a single point defined over an elliptic curve, or a single point of an elliptic curve. And the nice thing about this is that it gets you the succinctness property. So all the way back to like this transcript is really short, and the process is quick. Like the polynomial commitment schemes added to NISX really is what give you this ZK snark. So if you go back in kind of I don't think I have so ZK snark defining it. I wonder if I have, here we go. ZK snark defining what is ZK snark. So we got from IP to ZK snarks. By the way, Aleo is ZK snarks, is a ZK snark, and as are many other most ZK protocols in Web3 use ZK snarks, and I'll talk a little bit more in detail about that in a second. But maybe quickly, for the definitionally inclined among you, ZK snark stands for zero knowledge, succinct, non-interactive argument of knowledge, right? So we talked about what zero knowledge means already. Succinct means that the verifier is quick and the proof size is small relative to the statement being proven, right? So that means like basically it should be faster than rerunning all the work. Non-interactive, I talked about what that means. Argument of knowledge is just, it's the proof basically. Okay, so we had, like I said, a Schnorr was like one of the original schemes for as a Sigma protocol. Then you had this concept of probabilistically checkable proofs, and then this kind of led to the first ZK snarks, right, which is Pinocchio and then Groth 16. Groth 16 was used in the Zcash protocol. Actually, I think Pinocchio. I think the first iteration of Zcash may have actually used Pinocchio, but I think it was Sapling that used Groth 16, which is named for this cryptographer named Jan Groth, who came up with this construction for creating a ZK snark from a specific polynomial commitment scheme. And so this Groth 16 kind of snark was really the first one that everybody started using. And then you had a proliferation of different schemes that more or less take the same idea and improve it somehow. So Starks, some people may have heard of because of the company Starkware. Starks are actually a type of ZK snark. It's very confusing. Stands for something slightly different, scalable, transparent argument of knowledge. But their kind of thing is like the prover is slightly faster, right? The verifier and the proof size can vary with the size of the statement, although not by much, but the prover is faster, right? Plonk is another proof system that uses this concept called lookups, which is effectively like, hey, if you have these operations that are very expensive to do in ZK, because for a variety of reasons I won't get into, there are certain operations which are very cheap in like a typical computer architecture, right? Like adding two numbers or doing a bit flip, that are very expensive to do in ZK, right? This kind of has to do with the cryptographic domain over which these things are defined. The bottom line is Plonk's innovation was like, hey, we don't have to worry about doing this complicated cryptographic operation to convert all these things. We'll just generate a giant lookup table and basically prove that the inputs and the outputs map according to the lookup table, right? Marlin is another proof system that expands upon Groth 16 by enabling people to prove any general statement as opposed to a specific one, and Halo 2 is similar. So there's a whole proliferation of these different things on the ZK snark side. Okay, and so, yeah, what are they good for? I mean, this is kind of when I want to transition to talking, like, what's the point of this? So I think, like, for me, I think the reason why this technology is really impactful is because before, or maybe not even before, in the real world, like there's always a fundamental tension between proving something is true and hiding the information. Like I usually use the example of poker, but let's take a different example. Like since, I don't know, a more relevant real world example, like nuclear arms control, right? Like you in order to ensure nuclear arms control is, protocols are being followed or treaties are being followed, you need to allow inspectors onto a site to physically see and verify for themselves that these treaties are being followed, right? And that's the only way to do it. If you don't let the inspectors on, you have no way to know for sure that this treaty is being followed, right? So there's this tension between, like, you have to reveal everything inside this facility to prove that you're following the treaty, or you don't prove you're following the treaty, but no one then can know whether you are or not, right? So ZKPs break this paradigm. And this is why I think it's really cool. There's no physical analog for this, right? You can prove a statement is true without revealing why. So it's the equivalent of, like, just letting the nuclear arms control inspectors like have like a magic 8-ball effectively. They can say it's like, is it true? Yes, right. And that's cryptographically as good as actually physically seeing it, right? So it enables like a whole different, basically it's a whole new paradigm for privacy preserving computation, which is really what Aleo is all about, right? So fundamentally, I think, I talked about the concealment of information, right? And also the scalability properties allow you to compress information. The compression of information is really how all the rollups work. Okay. I think the one thing I do want to say here is that, maybe back to the marketing comment, I think ZK gets used a lot. I think the one thing is, like any other, computational paradigm, there's always trade-offs, right? Private ZK works for a lot of use cases for ZK computation. What is it not as good for? Well, it's tricky to apply when you have a computation that's running over shared state, right? Because in the model, like in this model, we go back to the IP thing, right? There's a prover and a verifier, right? So if you have like two people that want to make a proof about orders on an exchange, you still have to figure out, okay, whose trade went first, and like no single party has all the information to generate the proof about how their state transition would affect the price on the exchange, right? So these it's not a perfect fit for every use case. There's a bunch of workarounds, and we think about this at Aleo all the time. Happy to take questions on all this. We've got some questions in the chat actually, so maybe should I take these as I go? What's the preference of the moderators here?
You can if you want. That's totally fine,
Okay.
but we're also going to do a Q&A at the end. We're collecting the questions in a separate place, and I can ask all of them from you at the end, whichever you prefer.
Okay, I will. Okay, I'll maybe just wait till the end then, since we've only got about 18 minutes left or so, and I'll try and wrap up this portion of the talk in the next 5 to 8 minutes, and then we'll take a little bit of Q&A. Hopefully, this is good for people, good information, and people are getting some value out of this. And hopefully, it's not too low level or high level. Okay, so anyway, yeah, and ZKs also have their own trust assumptions. If you guys have ever heard of this concept of a trusted setup. It's a weird term I don't really love, but like the idea is basically like, when you are creating this or you're using this protocol, you need to effectively have a reference, some reference information that everyone uses to generate proofs and verify proofs. And that reference information or parameters need to be generated in a way that is not known by any single party or it breaks the whole thing. So without getting into detail, I'll just say that like ZKPs oftentimes have their own cryptographic and trust assumptions associated with them with their own trade-offs. So this is really, again, the takeaway here is like ZK is great. It creates a whole new paradigm. It comes with its own trade-offs, so we have to consider when building any real-world system. Okay, cool. Okay, I'm going to skip this and we'll maybe come back to it. Okay, so zero knowledge of blockchain. I'm going to go and talk a little bit about Aleo now. So, okay, everyone I think knows what a blockchain is. Is the idea is a permissionless, digital, tamper-proof, distributed ledger secured using cryptography, and the data is basically organized by time according to some tick, and then separated by these blocks generally. Money was the original motivating application. And this is kind of I just gave a talk about this, about how there's 40 years of protocols preceding Bitcoin. That people try to do digital cash. And Bitcoin's real innovation was permissionlessness, right? This ability to be able to do things in a peer-to-peer manner. And this, in how do they achieve that? Through cryptoeconomics, this kind of economic game that miners played around, like, hey, if you follow the rules, you get profit, you profit. If not, you don't profit, right? So basically taking advantage of an economic model to create a permissionless system where you didn't need to trust other parties on the network, right? Ethereum took this idea and said, hey, this is great, but this is kind of just like for simple money transactions. And by the way, you can't even really do money because you're not able to issue any kind of like currency on here. I know it's not strictly true with colored coins and everything, but generally speaking, Ethereum's critique or the motivation behind Ethereum was, let's expand this to include general smart contracts. So expand the programming model of Bitcoin. So Bitcoin, if you think of Bitcoin's innovation as being permissionlessness, Ethereum's innovation was programmability. What Aleo is trying to do effectively is to create a permissionless, programmable, and private paradigm, right? And so for me, and this is actually, I have another deck which kind of goes into a little more detail on this. Maybe I'll pull it up during the questions if people are interested in. I think permissionless, privacy-preserving programmability is really a key primitive to enable real-world use cases. What type of real-world use cases? Things like identity, things like finance, or like stable coins, where you can prove compliance effectively without having to reveal your transaction. So a better version of digital cash, etc. So this is another way of viewing it. So this is like Aleo is basically taking this zero knowledge cryptography, applying it to some of these innovations that have come before to enable this privacy preserving system. A lot of times I get this question, particularly at a conference such as the one I'm at, which is an Ethereum conference, which is like, why do a layer one? I'm not going to get into my philosophical arguments about, or semantic arguments about what is a layer one and what is a layer two. It's not worth delving into, but I guess in general, I would say that Ethereum and Bitcoin are both built with a specific application in mind. I think in Ethereum's case, the specific application is actually just general programmability or a general, VM, and it's not optimized as a kind of cryptographic prover or verifier, right? So like for performance reasons, for that thing, we decided to build our own layer one from the ground up to enable that. And I think there's also major security, privacy benefits to that as well. And then lastly, I think decentralization. To me, I talked about my background. I work with Syrian rebels. Like, this is people that didn't have access to the traditional financial system. The Kurdish people that we also work with in northern Syria, like they literally didn't have passports, right? So people like that, who I think are, honestly, potentially the biggest beneficiaries of this technology, like they can't access the permission system. So permissionlessness and decentralization is an essential quality there. Okay, so this is, I'll let people read this, but this is kind of one definition of what Aleo is. Permissionless, programmable, privacy preserving. Okay, I'm probably going to skip this part and then we'll go to questions. Let me just go through some quick use cases for ZK. Okay, talked about regulated stablecoins. I think, in my opinion, there's two major components of, or two major application areas that have seen some product market fit. I think one is stablecoins generally. I think a lot of people like to use stablecoins for remittances today. I think you see this in Turkey, the country that I'm currently in. You see this in South America, Venezuela. You see this in Nigeria. You see this in Eastern Europe, right? So people use stablecoins effectively for remittance purposes because it's way cheaper. What's the downside? Why don't we use stablecoins to buy coffee or get paychecks? Well, they don't have privacy, right? What's the downside of having a paycheck or a payment platform with only privacy and no ability to follow any laws? Well, every government in the world bans you and says, hey, you're not allowed to, this is not legal tender, right? But here in this model, you can have any issuer of a currency can just define what the rules are by which you can exchange that currency, right? So this is kind of like sidestepping the question of like, what should private payments be, and passing that off to kind of where I think that question should sit, which is with, hopefully elected governments and, and political systems of various stripes can all make that decision for themselves, or even just individual communities, right? If you're talking about something less dramatic than like a currency for a country, like even just a simple system of like, like a fee, quote unquote, like monopoly money or fiat money or something for a game or something like that, right? However you want value to be transferred, you can define under what conditions that's transferred, but by just proving that this, the constraints were satisfied as part of generating the transaction, right? I think dark pools, speaking of staying on the financial theme, something like, again, blockchains, I think have a lot of financial motivating use cases, dark pools being one that's not really possible to do on Ethereum or Bitcoin. What is a dark pool? It's basically like an OTC style exchange where you have parties that want to trade large amounts of a specific asset, buy or sell. They don't want to reveal who they are necessarily, right? Not possible to do on the model of Ethereum or Bitcoin because despite, and maybe this is a good point, I'm assuming everyone who's watching this knows this, but Bitcoin and Ethereum are not anonymous. They're not privacy preserving. Why is that? Because all of the computation, all the data for each computation has to be posted onto the chain as part of the security model. So PSA, in case people weren't aware of that. Okay. Proof of solvency, people have talked about this for exchanges. Exchanges want to show that they're solvent, or I guess in the case of FTX, maybe they don't want to show that they're solvent or don't want people to know they're not solvent. But anyway, for most, I would say legitimate exchanges and ethical people in the space, maybe you want to prove solvency without revealing, exactly what the state of your balance sheet is, right? I think this could be another use case where stablecoin issuers may want to do this. Identity is a huge one that I'm really excited about. I think there are a ton of identity applications that just remain problems on the web. Let me just give a good example. Age verification. There's a ton of content online today that I think most people would not want a child defined however you want to define, but like a child to not access, right? There's a lot of age restricted content online, but there's not really a good way to block that age restricted content. I mean, typically what you see for a website, let's just say if you want to go, a simple example is like buying wine. I think technically to go to a website that's advertising wine or cigarettes, I think in the US, you have to say you're over 18 or over 21, but you just say you're over 21, right? So drop down menu. People may have seen this. There's a drop down menu that says, when were you born? Another example is video games, right? If you want to like download a video game off of Steam, I heard the group talking about EVE Online earlier. I don't know what EVE Online's rated, but like there's a pop-up that says, when were you born? And then you just pick whenever you were born, right? So we maybe want to solve that problem. There's not a good way to solve that problem today, but I think a privacy-preserving layer for computation is a platform upon which you can build a system for digital identity that doesn't just, Jimmy's point, are you older than 21? Click yes, exactly, right? So Aleo's system, I think, can enable people to create a new paradigm for identity where you can prove you're over 21, you can prove you're an American citizen, or you can prove you're not an American citizen or whatever, right? Without having to reveal anything else about you. Okay, we're getting lots of good questions here. I guess I gotta finish up so we can get to the Q&A. So let me just run through the rest of these. I think those are the big ones that I see. Oh yeah, maybe it's a good point. Yes.
If you're fine staying over a bit, we can just
I can
take all the questions afterwards. So don't hurry too much.
I can stay over, and this is pretty close to the end anyway. I think secure private voting. There's a whole controversy around whether voting should be done online or digitally. I'm personally an advocate for it because I think it enables more participation. But I think it's certainly the case that if you do if you are an advocate for it, you need to ensure that there's some level of privacy preservation for individual votes. Interoperability is another really cool one. So ZK, again, these are, you like zoom out from Web3 use cases. I think Web3 use cases being a lot of the payment stuff that I focused on here. What we can go back to what is a zero knowledge proof, going back thinking about IP and all this stuff. Like, the great thing about ZK here is you're just proving arbitrary statements, right? They don't have to be statements about money. They can be arbitrary. And one of the things you can do, which is really cool, is in a zero knowledge proof, you can do something like verify TLS signature, right? And so why would you want to do that? I don't know. I mean, for example, maybe you want to prove that you received an email from a certain party, right? Or maybe you want to prove in the example of identity, my passport has an NFC chip with a digital signature signed by the U.S. government, by the issuing authority, right? So you can basically you can prove the verification of signatures, for example, inside of a zero knowledge proof, and that kind of is a way to create a portability for data, right, and interoperate between systems, whether they're on Web 2 or Web 3. I think that is actually, I think, kind of the key primitive that enables the future of like privacy preserving machine learning. I have ZK machine learning out here, but I think better is privacy preserving machine learning. I think, for example, I think ZK paired with, for anyone who's interested in AI ML, there's this technique called federated learning, where federated learning is this idea that like you basically train a model on your device, or you kind of run a model on your device and you kind of send the results to a third party server, right? And the server alongside, the ZK part comes in alongside that training, the result of your model. You can attach a zero knowledge proof that says, hey, I'm attesting to the fact that I actually trained this model according to whatever, I'm not just trying to spoof you. This is actually correct in terms of what you asked me to train, or the way you asked me to train the model. And then what's the advantage of this? Well, you don't have to reveal your data to OpenAI or whatever, but you can benefit from a more personalized model, right? And I think that's where the future is for machine learning around, like, ChatGPT. I think it's maybe good. I think in some ways overrated, but I think for that to get better and better, it's not about the model necessarily getting better, or maybe it is to an extent, but it's largely about the type of personal data that the model is able to be trained on, right, that affects you and you personally. Cool. I think there's a bunch of cool gaming applications. Dark Forest is an example game using zero knowledge deployed on Ethereum, or I think it's actually some Ethereum layer 2. But really cool idea of what you can do there. I think it kind of opens up a whole new world for blockchain-based games. Okay, cool. Maybe, so Aleo, maybe this is a good time to say, where are we? We're getting ready to launch mainnet January, and mainnet, by my definition, is like fully permissionless, so anyone can run a node, anyone can deploy a program, anyone can do a transaction. I can't stop you. And that's, to me, that's a blockchain. That is going to be in January of this coming year. I said end of year. We were actually supposed to do end of year, but we decided to delay for because of some partners that we're working with on the custody side. Okay. Some quick closing thoughts, and maybe I'll talk a little bit about NIM here in this part. Okay. So I'll talk about ZK, what it is, why I think it's special, which is really because it overcomes this tension between verifiability and privacy. I think, though, to me, the combination of zero knowledge cryptography with permissionless software and blockchains is really, I think, critical for enabling certain use cases like identity, right? And I think there's a lot of projects, like I said, kind of talking, about the existing Web3 ecosystem. There's a lot of projects that use ZK, and they maybe don't necessarily care about the blockchain-based component. But for me, going back again to my background, like the permissionlessness aspect of this is super important to me, right? Because I think a lot of times we talk about use cases, it's enabling financial inclusion, et cetera, and I think permissionlessness is a key part of that. And I think we're a little bit too quick to forget that. And I think sometimes, and this is maybe like more kind of high-level thought on privacy and why that's important, which I'm probably not going to blow your guys' minds, but like, look, I think we kind of have this idea, especially just given the last several generations of humanity, where life has just gotten better and better and better for everyone, that's just guaranteed, right? And I don't think that's always the case, right? And I think particularly when it comes to individual quality of life, which is, I think, a function of individual liberties, I think you're starting to see, you may have already seen the high watermark of that. I think digital technologies outside of cryptography largely enable more effective centralization large authorities, right? And I think at the expense of individual liberties. So I think it's just something to me that like is important to remember around like what's the importance of privacy preserving technology is let's make sure we're not that we're not creating a system for ourselves in which we might all regret later, right? And Aleo is obviously part of this at the computation layer. Here's some resource. Aleo is obviously doing this at the computation layer, but I think NIM is obviously focused on this on the network layer. And maybe this is a good time to talk about NIM and how Aleo and the two could potentially interact. It's like I said, there's a layer for the execution of programs, but then there's a layer where clients need to communicate with the network, right? And clients communicating with the network, even though the computation itself is privacy preserving, you might leak all the information about your computation via the metadata or via the messages that you're sending over the network, right? So this is where I think NIM's MixNet comes in, and I think it's a really interesting idea. And paired with Aleo, which you basically get as a fully privacy preserving stack. So I think that's the interesting opportunity. And maybe with that, I'll stop and we can turn it over to questions. There's a lot of great questions I see in here.
Thanks for the excellent presentation. But before all of those great questions, I'm going to ask my own because I get to do that. I'm the host. So I'm going to ask this question from Max because actually this is something that I'm pretty interested in. It sounds like there's quite a bit of synergy between possible synergies between Aleo and NIM. What would those be? So how would you see these two networks working together?
Yeah, I think like the example that I would see is like potentially, in the future that I would love to see is like, you have users of Aleo also running NIM clients, right? Where it's like, you're basically using a NIM client to send messages to the Aleo network, right? Thereby, ensuring that the messages, like your intentions about actions you want to take on the network, are not inadvertently leaked in the transport stage, right? Transporting those intentions from your device to the network, right? Or honestly, even if you do I guess like Aleo's got an off-chain computation model where you're generating the proof yourself, right? So it's not necessarily that you're like sending a message and revealing everything about your computation, but enough metadata could get leaked to invalidate the whole value proposition of Aleo. So to me, I could see these things basically being, it's like one is sitting underneath the other in terms of a stack, right? I think you guys often talk about yourselves as layer 0. I talk about ourselves as layer 1. I actually like that framing. I don't like the layer 1, layer 2 framing as much, but I think the layer 0, layer 1 framing is really good because I think this is kind of architecture that something like Aleo needs to be built upon if we do care about privacy.
I actually had a question as well regarding your networking specifically, partially just because that was what I was particularly looking at, obviously in the context of possible integrations and stuff, right? And in one of your blog posts, you actually also mentioned like mobile phones, personal computers, all of this kind of stuff. And from what I understand anyway of your networking, right, it's all you encapsulate all of it under Snark OS, which you kind of phrase as like this decentralized operating system, right? And so you have validators and you have provers, and then you have clients, like the users, I suppose, using light clients to interact, right? What's the difference in this context between a validator and a prover, right? Because you have a proof of work chain, as far as I understand it. Is the work the validation of proofs, or are you kind of like layering these two things where you actually have a normal, so to speak, proof of work consensus algorithm, and then you have proving on top? Could you kind of elucidate that a little bit more?
Good question, because I glossed over Aleo's consensus, right? And maybe let's go back and revisit that. So Aleo, strictly speaking, is proof of stake consensus. So we run an algorithm called Narwhal Bullshark, and so blocks are kind of created and come to consensus about on that basis. So it's purely proof of stake. That said, it used to be the last iteration was proof of work, and the proof of work component that got carried forward is this economic rewards component, right? So in our network, provers, at least as they're typically referred to, are entities on the network that are basically playing a lottery. The number of tickets that they get in the lottery is proportional to the amount of work that they're contributing, right? So it's like Bitcoin in that way, except it's not relating to block production, right? It's just purely about economic rewards. And there's maybe the natural motivating. So like that's what we mean by a prover in this context. Now that said, it's important, before I talk a little bit more about provers in that definition, it's important to note that to interact with this network, everyone is a prover. A client, if they're sending a transaction, is a prover. Why is that the case? Because to generate it, an Aleo transaction is a ZK proof, right? And there's no requirement to go through a centralized third-party server that we run. And this is, by the way, how many ZK rollups work. There's no single entity that you have to go through to generate a zero knowledge proof. So you as a client can generate a proof. So in that sense, you're also a prover. But we refer to provers as basically performing this work for the network and getting a part of the block reward each block, right? Now, the reason we have that is because one of the drawbacks of ZKPs, I didn't mention it explicitly, but some of you may have seen it on the slide, is they're computationally intensive, right? So there can be several orders or 10,000x higher cost than just doing a computation natively, depending on the application or computation, right? And one way to bring those costs down is hardware acceleration, right? Or having hardware, basically some of these algorithms baked into existing hardware. But as with anything else in hardware, this is very capital intensive and it requires a big capital investment. So the reason why we put this economic incentive into the protocol is to try and encourage, people to look at this economic incentive as potentially the upside for capital that they would invest in making proofs better, faster, cheaper. And this, by the way, it's important to note that the proofs that provers do for the protocol, the work that provers do for the protocol, is 99% carried over or could be carried over to generating proofs on their own, right? Or proofs for users. I talked about how users can generate their own proofs. Users can also choose to outsource proof generation to a third party, right? Mm-hmm. So the idea is to bootstrap that ecosystem because right today there's a chicken and egg problem. There's no proving as a service ecosystem because there's no demand for proofs because there's no proving as a service ecosystem, right? So this is kind of meant to circumvent that chicken and egg problem. Artificially create demand for proofs, and then as applications come online at Aleo, have those provers and be able to service those applications. Is that helpful?
That's really interesting. And I mean, yeah, it also sounds like not only do we have a synergy in what the tech is trying to do, but there's also synergies in terms of some of the maybe not issues, but some of the some of the things that are maybe ceilings for performance, because obviously on the NIM side, then obviously you also have a similar thing where there's a massive additional amount of cryptographic work that's being done just to send a simple message to the network. You're having to create not only the actual packets themselves, but all this cover traffic, and this is all multiply encrypted. It's all exactly. Similarly, and we had Chelsea talking about possible hardware kind of optimization.
And if NIM gets adopted, right, there will be incentives by, if consumers demand this, there will be incentives by hardware manufacturers to bake in a lot of this stuff. I mean, an example I like to use a lot is I'm from the time of the dinosaurs, back when the internet was brand new. I remember in the early days, you would go to websites and HTTPS was not every website was not just HTTPS by default, right? Like it is today. Now, if I go to a website that's not using HTTPS, my browser literally warns me, right? But in the early days, that wasn't the case. Why wasn't it the case? Because running TLS on your client was slow, right? And one of the reasons that got fast because Intel actually baked in the instructions for some of these low-level primitives that AES was running that were very intensive, relatively speaking, into the chipset, right? And so then it basically, you're still doing this computation. Didn't make it faster from a computational complexity perspective. But from a real world human product perspective, it made a giant difference, right? And I think that's the same opportunity that exists for technology like NIM and for Aleo, right? So
I think in hardware as well, we're also seeing that in the everything. Well, they have a single board computer, but all this kind of RISC-V architecture as well, where obviously one of the downsides of all of this being relegated to Intel is it's Intel, right? It's it's a proprietary chip. They have a monopoly on this thing, and I think now we are seeing this catch up as well. But then I think even and obviously we're in the world of cryptography engineering, which goes slow because it has to, because you have to make sure it works, But I think our hardware is also
totally, and it's
a huge trade.
It's a trade-off, right? In addition to Aleo, I run this nonprofit endeavor called ZPrize, which is literally all about accelerating zero-knowledge cryptography and hardware. And a big part of the reason for that was because in the early kind of nascent days of, which is only a year or two ago, of hardware acceleration for ZK, what you saw is unlike the software layer, where generally the impulse was to open source, in hardware, everyone's impulse is to close source everything. Why is that understandable? Because the capital investment required is huge, right? So if you open source it, you just give effectively all your competitors the secrets, right? Now, what's the downside of that? To your point, well, if you just create a new Intel that everyone has to go through to buy the chips, like that's a failure point, right? That's a point in which your decentralization, your permissionlessness, kind of system breaks down, right? But it's also it's understandable why that is. So there's always a push and pull here, right? So to me, I think hardware acceleration, the key is making sure that what is open source, like what is kind of the best in class that's accessible to everybody, is not too far behind the best in class proprietary thing.
All right, note to self, Jaya, this is also note to you. We need to bring Alex, Max, and maybe Chelsea on for a community call or some kind of panel to discuss this stuff, because it's a fascinating discussion. But unfortunately, we have a ton of community questions, so let's jump into those. I think the first ones, so we got two questions on Nim and Aleo working together, so I'm not going to go into that, but part of it is interesting. So are Nim and Aleo partners?
So we're chatting about that right now. So conversations are ongoing about what that looks like. But I think philosophically speaking, absolutely the answer is yes, right? Why? Because we share the same goal of like enhancing privacy online for users. And what is that? What does that effectively entail or affect? It's consumer protection to me at the end of the day. The business way to say it is like you're protecting consumer data, for people that might want to take advantage of it. So it's better for consumers. So we're on that front, I think, very much already working together. I think in terms of explicitly how is Aleo and Nim going to integrate, I think as we both continue to evolve our stacks, like, there'll be more and more ways where we can kind of tie them together. And I think a big part of that will also be on how individuals in both of our ecosystems are using it, right? There may be natural synergies that kind of evolve as we kind of go forward and with our collective, our respective roadmaps.
Amazing. So imminent partnership announcement, Jaya? Question mark?
I mean, I'll stick with Alex's very well put together answer. But yes, conversations are absolutely ongoing. So that's true.
All right, folks, you heard it here first. Next question is: Will Aleo be using ZK NIMs? This is also from Jimmy. Thanks for the question, Jimmy.
Oh, I don't actually know what ZK NIMs are, so maybe is the answer.
So it's kind of it's NIMs. To a certain extent, it's our response to the question of identity, but it's a response in the form of sidestepping the question of identity, because it's not an identifier, right? These are ZK NIMs. It's what previously, they're an implementation of the Coconut credential scheme, which we've been kind of talking about for quite a while, which are these like re-randomizable, essentially like attestations. So you could imagine them also being used for like access control, but they're not identifiers. So there is ZK in the construction of them. You construct a proof about the statement. I don't know. I have paid for this service. I have access to log in here. I have the ability to do this. But they're not identifiers, which is kind of maybe the crux of the difference there.
So more like temporary throwaway credentials to prove the right to access the service. So initially, ZK NIMs are going to be quite specific to granting access to the NIM VPN, so proof of payments essentially. Before we start thinking about something more general purpose. So initially, it's quite a specific implementation.
And I don't want to derail everyone else's questions, but I'd be interested to learn more about that because I think it's interesting. Yeah, I think authentication is a use case for identity that we think about a lot. It'd be cool to learn more about that.
Definitely.
All right, thanks for the answer. There's a huge derail risk present in this stream, by the way, and I love it. It's really great. Okay, so wait, what was the next one? Yeah, so why make ZKs non-interactable faster or more trustless? Morgan is asking. Thanks for the question, Morgan.
Yeah, I just think for certain applications like payments, for example, right? Like you kind of want. I think people typically want this push payment, system. It's like this concept of like I can just send you money and you don't have to like say yes to getting the money. I actually think there are some use cases where you do want to say yes to getting the money. Have a more of a pull payment system, but for a use case like a push payment system, for example, like you want it non-interactive because I want to be able to pay you without your permission to like receive. Like you don't need to give me permission to receive money from me, right? So it's kind of an example of where like the non-interactive schemes. I guess I'll just maybe say they're just more flexible in what they can handle. And more for practical everyday use cases than the interactive schemes. That's sort of why people trended towards using these non-interactive schemes.
Thanks for that answer. Another question from Jimmy. Why ZK solutions may not be optimal for shared networks as highlighted by Aleo?
Yeah, it's not networks. It's applications that share state, right? So like the classic example that I love to talk about is Uniswap. For people who don't know, Uniswap is a DEX, it's a decentralized exchange deployed on Ethereum. And what it really is it's a factory contract that creates a bunch of child contracts that basically consist of three things. It's a two assets, right? A pool of two assets, a number of, an amount of assets in a pool on both sides, and a function that relates to them, right? So, like, to trade on Uniswap, then effectively you're adding to the pool on one side, right? And then getting from the pool on the other side. And the relative asymmetry of the pool is basically what defines the price, right? Now, why is this hard in ZK? Well, the price kind of depends on what everyone's transaction was right before mine, right? Because the pool is moving up and down, and remember, these things don't happen atomically; they happen in a tick, which is 15 seconds in Ethereum, right? So, in one Ethereum time step, in one block time, you might have 100 people trading on the same DEX, but I don't know what the price is exactly going to be because I don't exactly know what order I am in that list, right? So this is why it's complicated. This is why people talk about sequencers a lot in both rollups and in ZK, where it's like you kind of need to reintroduce this party that can like basically do what Bitcoin solved, right? Which is like come to consensus about the order that things happen. And so that's kind of the extra complexity that gets added. Now, Aleo, how do we sidestep this? Well, we don't really for the private state. Private state is tricky. I think there are solutions that use trusted hardware, like a trusted execution environments, TEAS, SGX is an example, where you can kind of do this. I mean, networks like what used to be called Enigma, I think they have a different name now. Anyway, there's like certain blockchain networks that are built around TEAS, right, that enable you to do this in a privacy-preserving manner, so long as you're comfortable with assuming that like Intel is like, like you're relying on their hardware, right? But I think Aleo sidesteps this by also giving people the option to do public state like Ethereum, right? So public contracts like Ethereum, right? So you can basically marry both private logic and public logic in one program, and then maybe not get the perfect like fully private DEX like Uniswap, but you can get like kind of a best of both worlds in a sense where like you can access and update shared state within one time step, and you can like hide the identities of everybody who's trading on the DEX, for example. So it's like better than Uniswap, but not quite as good as you would want with like, fully private dark pool, which of course has its own problems of like you need to trust whoever's operating the dark pool. Hopefully that was confusing and helpful.
It's actually I don't know, there is definitely a parallel there. I'm not 100% sure what it is, but it's really interesting these discussions as well, because we're kind of back to a certain extent. You're for the fully private stuff, you're almost having to, without reinventing the wheel, to a certain extent, move back to away from the kind of like a general purpose computation that something like Ethereum was initially kind of espousing, because it's when everything's transparent, you can do general purpose distributed computation like relatively easily because you can see everything versus what Penumbra is doing, for instance, where the entire project of Penumbra, at least like the first major thing that they're like really focusing on, is essentially this, right? It's how do you do private order books? How do you do stuff like dark pools? And that's, involved a massive amount of like, just straight up cryptography research as well, let alone the actual implementation of that. So it's also an interesting tension as well, when maybe to step back a bit, when people are used to the ease of having general purpose kind of distributed computation, like it's privacy stuff has to be a lot more focused just by design as well. You know what I mean?
Yeah, and all these systems have constraints, right? So like so like ZK like Aleo's ZK VM is not Turing complete. No ZK PVM can be Turing complete. Why?
course.
Well, why can't it be, right? It makes sense if you think about it,
does.
because these interactions have to be defined as a transcript, so you basically need to know exactly how the program is going to execute at compile time, which is not. That's literally the opposite of like what the what a Turing complete definition is, right? Now, Ethereum, I kind of like talking about this because I think people kind of talk about Ethereum and the EVM as being Turing complete, but it's not really, right? Because if you think about how is it not really, well, because like when is it going to halt? Well, it's going to halt whenever the program runs out of gas, right? So it's Turing complete if you like only consider it in isolation, but when you consider it in the context of everything else, it's not really, right? Because the thing's going to halt when you run out of gas. So that actually means that there are certain constraints in that paradigm too. That, by the way, ZK does not have. Let me give a concrete example in case I just confused everyone. Like, let's take something simple like a basic classifier algorithm, or even a linear regression, right? A linear regression, to run that with even like 100 points on Ethereum would blow the gas limit sky high, right? So you're never going to be able to run that computation on Ethereum, right? Now, the nice thing about ZK is that I can run that, and even if that computation takes 100 years to prove, like that proof at the end of the day is the same size as a proof that took 10 seconds to prove, and it takes the same time to verify. So the runtime of an actual program in the context of a broader system could be much bigger. So even though, strictly speaking, a ZK VM like Aleo is not Turing complete, and an EVM like Ethereum is, in a sense, the capabilities are actually very different. And one is, in some ways, the latter is more limiting than the former. And I think it's just like this. These are things you learn as you get into these systems. You dig in. You kind of like learn to take nothing for granted. I mean, another thing about distributed networks that your comments kind of bring up and these questions bring up is like time. Like in a decentralized net, you guys probably think about this on the networking standpoint. When did a message originate? When did I receive the message? Like, it should be a simple question, but there's like you can just go down the rabbit hole of like thinking about time and how it's kind of all relative, right? And then the implications of that in how you design the software. So,
yeah, I was
100%.
having a big discussion with our head of engineering about the epochs in our system recently. Yeah, you can. It is a rabbit hole, and it can get very poetic very quickly as well.
So simple. Another good one that I like that no one thinks about is randomness. Like, you're just like, oh, just pick some random numbers. And you're like, oh, it shouldn't be too hard, but it is hard. Actually, it turns out it is hard. Like, generating random numbers is actually a pretty hard engineering problem that gets hand waved all the time in cryptography. You're like, oh, it's a random oracle, blah 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 blah. But like the entropy needed to generate true randomness is actually limited, right? It's a limiting factor in a real world system. And by the way, there's many examples of protocols that are otherwise secure that have been broken because of bad randomness assumptions.
Yeah.
Yeah, vanity address generation as well can cut your randomness. So even though your vanity address looks cool, it can actually make it far easier to brute force.
That's right.
But yeah,
right.
I mean, the timing stuff is something that so I also I co-wrote the foreword to a philosophy book about time. So, but on a more concrete level as well. Then it's
drop the link.
Yeah, well, it's a wild book. It's wonderful. It's a PhD thesis from the millennium that got republished or published IRL for the first time. But yeah, it's also really interesting because even when you're thinking about how you integrate or how you can integrate existing stuff, right? If we think about like even just HTTPS or something like a really or like a TLS handshake, right? Really basic part of authentication on the web, kind of as it is today, then that requires, like, NIM to a certain extent breaks that model, because it's like your packets may come at different times. You don't have this concept of a stream. These are all these, like, again, additional constraints that you're kind of adding here. And I mean, with blockchains, actually, it's quite nice because you don't have these concept of streams, right? You're pushing messages into another distributed network, which is why it's quite the integration of the marriage of these two things works quite well.
Yeah.
Yeah. Are there any? I mean, sorry, let me rephrase that question. I kind of tried to ask a question halfway through a tangent. Are you already seeing kind of people begin to build either with like Leo or kind of like build out? I know you're in the third round of your test nets now.
Yeah.
But I was having a look through some of the stuff that was some of the stuff that was deployed on the network. And are there any particular like issues or are these constraints something that have like kind of come up that you've had as like feedback from people who are trying to do stuff on the network in this in a slightly different
Yeah.
paradigm of how you actually have shared state, the things that you take for granted, maybe in other programming environments or distributed environments. Are you
Yeah, I
running up
think one
against any
thing,
of those?
one challenge that we face candidly is there's a tension here between the ease of programmability on a fully transparent smart contract platform, which we enable, right? Because we enable people to deploy public contracts, but the effect that has on the effectively the anonymity set, right?
Yeah.
So it's like it's easier to just write transparent everything.
Yeah.
But then if the whole world is doing that and only one person is doing something privately, well, it's pretty damn easy to figure out who that one person is, right? So the anonymity, ensuring the anonymity set doesn't shrink down too much is a big thing, right? So like I guess at best, and this is good, at best we have the anonymity set is every single user of the Aleo blockchain. But that's kind of the ideal, right? In reality, and what we've seen a lot of people do on these things is do what is familiar, do what's from Ethereum, right? And as a result, they're kind of like they often reach for this like the public contracts, these public, like we call it mappings. It's just this like this public shared state. And that I think as a result kind of reduces the value prop for the privacy stuff a lot. And I think so we try and but that's kind of been the inbound is people like that stuff because it makes programming easier. It makes the developer experience easier. Because this is the other thing about this model is like the programming model is actually kind of really weird for a developer standpoint. This is something that I didn't even realize until getting into this space. It's like you think about writing a program typically on a language like JavaScript or Python. You're like, okay, what do I want to do? I'm going to type some logic to do it, right? And that's the thing. That's your script, right? In this model, though, you actually to do on the privacy preserving side, you kind of have to work backwards, right? You're like, okay, I have a user that has some private state only known to them, and there's a program that they input this private state, and then only if the private state satisfies the constraints of this program, does the thing happen. You get what I mean? So you actually kind of like have to write the program backwards, effectively, logically. And so it's like it's a hard model for people to grok, honestly. And this is not just an Aleo problem. This is like privacy preserving or ZK VM generally. Like anybody writing this model has to kind of think it through it that way. So anyway, so what do we do about it? We try and lead ourselves with or showcase what you can do in this model. Why is it worth learning, right? So we have this product called CPass, which is an implementation of a great paper I recommend everyone check out called ZK Creds. And the idea is basically taking a passport, scanning the NFC chip, verifying the signature from the issuing authority, and then doing an age verification, right? So you're verifying the information on the NFC chip, verifying the signature, and then proving your age without revealing it, right? So that's like kind of, you need the privacy preserving model to do that. And so we've built that to showcase, hey, this is what people can do. We turn that into an SDK that people can easily basically take that primitive and then build on it, so they don't have to reinvent the wheel or think, kind of reverse how they typically think about things. Similarly, like we have a model where we let like ML developers. We have a library in Python that's whatever the package manager is for Python, which escaped me right now, but like we have the ZKML package there, which basically lets people write Python code and it just transpiles to Leo, and like that kind of takes some of the complexity of being a developer out of it. It improves the developer experience.
So I think I definitely need to run, but I think we have so much material here, and it feels like a philosophy panel and a hardware panel might have to happen at some point.
I'm sorry,
and
I'm
an
very
AI panel.
verbose, but I hope
This is fantastic.
I hope I gave everyone their name. Let me just run through real quick, Jaya, and see if I'm just going to rapid fire answer, see anything we didn't get to.
One question that I definitely like you to answer, because it was not only asked by the chat, but also our very own Merv, who was the very first community manager of NIM ever. So she's a true NIM OG. She's a big fan of Aleo, and she's asking why you guys have your own programming language, because it may pose difficulties, for people to integrate and like learn it. What's the decision making process?
So I'll end on this one because it's a good question. Then everybody else, I will. I'm sorry to disappoint you, but I'm happy to answer questions on our Discord, or people got my Twitter. I think I put my Twitter handle up when I shared the screen. People can DM me or whatever. But anyway, so why our own programming language? We're targeting a fundamentally, like the low level target is fundamentally different, right? So like JavaScript is kind of targeting, the LLVM or WASM, right? So executing, you need to think about the execution environment, right? So where is JavaScript being executed in the web in a web browser, right? And here, like, we'd like that to be the same, but like what's actually being compiled from this high level logic? It's cryptographic proofs. How are these proofs defined? They're defined over elliptic curves. They're fundamentally different objects, right? The computing model is different effectively than the bits and bytes that your computer machine is used to computing. Right? Now, of course, it's still your computer computing it, right? But you're emulating this cryptographic object in that setting. And so you need to do that performantly. You need to have a compiler that is optimizing that logic down to that low level cryptography, right? So it's actually not even the language itself that's special. It's the compiler architecture for the specific runtime environment, which in our case is this off-chain execution environment that's verified on-chain, that makes the language necessary. And the last thing I'll say is, like, people always love to say, they're like, no one wants to learn a new programming language. That's bullshit. Developers will learn a new programming language if it helps them. And this is, I think, and there are other ZK DSLs out there, but Aleo is one where this is the only way to do privacy-preserving computation that exists today, to my knowledge, right? And so I think that's one of the reasons why we did it, because we had to, and also I think why people are going to be looked.
Thank you for that answer.
I think that's a great place to end. Alex,
Yeah.
for just a couple of minutes after we close the stream.
Sure. Yeah, I'll stay on.
Before closing the stream, we have the outro ritual that I need to do. So, for context, Alex, for people so if people attend these events, these shipyard events, they get a POAP to commemorate it, and we have a secret phrase every event, which people can use to claim the POAP for a limited time. So, guys, thanks for joining this one. The secret phrase for today is privacy primitives, which is provided by Jaya, and it's also becoming a tradition here at shipyard events to ask our participants why this given phrase is relevant to their talk. So do you want to riff on that a little bit? How is it relevant to your lecture?
Yeah, I mean, I think we're both building privacy primitives, right, at different layers of the stack, but enabling people to build privacy-preserving applications that fundamentally protect user information and ensure consumer protection and enhance the liberty of people who are using the web for all kinds of very legitimate use cases, and then unlocking new use cases that can't be captured with the existing tech stack. How was that?
Perfect.
Perfect.
Nice.
All right.
Big thanks again for joining, Alex. Let me quickly give people the link as well. So you need to go to nimtech.net/go/POAP to claim your POAP for this guest lecture. I can't speak. And Alex, you can also claim your POAP if you want to within the next 15 minutes. Now,
all right.
The next steps are there is going to be a fireside chat workshop event by Serinko at 4 p.m. 3 p.m. UTC today with an AMA as well. So if you have any questions about operating nodes, then make sure to bring those there. And tomorrow is going to be the grand graduation ceremony of Shipyard. So make sure not to miss that, because there's going to be some pretty important information shared with you about how to move forward. That's all I'm going to say for now. Huge thanks again for coming on to all three of you. Alex, we definitely got to have you back at some point for a hardware and maybe philosophy of privacy kind of discussion.
Great.
This panel already looks good. Maybe we'll add a few people here and there. It was really nice to meet you.
Yeah, it was amazing. Thank you guys very much for hosting me. I really enjoyed this.
Right, and with that, have fun, everybody, and see you all in a few hours.